All right, let's pull back the curtain on something we do every single day without a second thought. We're going to uncover this secret, high-speed story that plays out every time you click a link and a web page just appears. Let's dive right in. Think about it. You do this constantly. You click, and boom, in less than a second, a whole new world is right there on your screen. It feels like magic, doesn't it? Like it's totally instantaneous. But what if I told you it's anything but?
Yeah, it's not magic at all. What's really happening is an incredibly fast, perfectly choreographed conversation between your computer and another one, maybe thousands of miles away. Every single click kicks off this lightning-fast back and forth.
And to actually see this conversation happen, we're using a special tool called Wireshark. You can think of it as a network microscope. It lets us be a fly on the wall, capturing every single message sent between computers, so we can see this entire invisible journey from start to finish. Okay, so before any real data, the actual website can be sent, the two computers have to introduce themselves. They can't just start shouting at each other. There's a protocol, a polite way they have to say hello first. This is called the TCP three-way handshake. And honestly, the easiest way to think about it is like making a phone call. Your computer sends a SYN packet. That's like dialing the number and saying, "Hello, are you there?" The server on the other end replies with a SYN/ACK, which basically means, "Yep, I'm here and I hear you loud and clear." Finally, your computer sends one last ACK packet to confirm, "Awesome, I hear you too, let's talk." Only then is the line officially open. Now, for these messages to get to the right place, they need an address, just like a letter you'd put in the mail. The IP address, that's like the main street address of the server building. It gets the message to the right computer, anywhere in the world. But once it gets to that building, how does it find the right program inside? Well, that's where the TCP port comes in. It's like the apartment number or a specific doorway that guides the message straight to the web server application. And for standard unencrypted web traffic, the stuff that uses HTTP, that specific doorway is almost always port 80. You can think of it as the universal front door for most websites. So our message knows exactly where it's going. So the handshake is complete, the connection is open, and now our browser can finally send its first real message. The mission is officially underway, to go get that web page. This message is called an HTTP GET request, and it's a beautifully simple thing. It's really just a little packet of data that says, "Hey server, could you please get me this specific web page?" This GET request is the real hero of our story. It's the messenger carrying our command. Let's take a quick peek inside that request packet. The host field tells the server which specific website you want, since one server can host hundreds of sites. The user agent identifies your browser. Are you on Chrome, Firefox? So the server can send back a compatible version of the page. Then you have other things like refer, which gives even more context. It's all the info the server needs to do its job right. As soon as the server gets that GET request, it doesn't just go quiet. Remember, this is a conversation. It immediately fires back a tiny little TCP ACK packet. This is just its way of politely confirming, "Message received, I'm on it." So we've asked for the page, the server said, "Got it." You'd think the very next thing we get is the web page itself, right? Well, not always. Sometimes the journey takes a really unexpected turn. Instead of getting the web page, the server's first real response is this, a status code of 301. In the language of the web, 301 means moved permanently. And just like that, we've got a plot twist. What the server is basically telling our browser is, "Hey, I got your request, but the page you're looking for doesn't live at this address anymore. It has a new permanent home over here," and it actually gives the new address right in the response. Our browser doesn't even flinch. It's like a good delivery driver who gets a forwarding address. It just ends the first conversation, does a whole new handshake with the new server address, and immediately sends a brand new GET request to the correct location. And this brings us to the climax of our story. We've shaken hands, sent our request, followed the new directions, and sent a second request. Now we're finally at the final destination, and it's time to get what we came for. Success! The server at the new address responds with the code we've been waiting for, 200 OK. This is the universal signal that means, "I found what you asked for, and here it comes." Mission accomplished. But here's the thing, a whole web page, all that code and text, is usually way too big to fit into one single packet. So the server does what a shipping company would do with a huge item. It breaks it down into smaller, numbered boxes. We call these TCP segments. Your browser gets all these little pieces, maybe even out of order, and uses the numbers to put them back together perfectly. And this right here is the big aha moment. The raw, reassembled text data that Wireshark shows us, it's the exact same stuff you see if you right-click on a web page and hit View Page Source. This raw code is the actual blueprint your browser uses to build the visual, interactive page you end up seeing. And just like that, the journey's over. From a simple handshake to a request, a quick detour, and finally the delivery of all those little pieces of data, a stream of plain text has crossed the internet and been transformed by your browser into a fully rendered web page, all in the blink of an eye. So next time you click a link, remember, it's not magic. It's a complex and honestly a pretty fascinating conversation happening just beneath the surface. The only question left is, what will you listen to next?